Hi, I'm Sean Gannett, and this is Minute Math, and today we're learning about rational expressions.
Minute Math. When you need help, you use Minute Math.
We're given this problem right here, 60x to the third power divided by 12x, and we need to state the excluded value. The excluded value is the value here that we really just can't use. And so we know we cannot divide by 0. So that's generally our rule of thumb with a rational expression here. So if we can't divide by 0, that means the denominator cannot equal 0. So we take our denominator, 12x, and we set it equal to 0, and we need to find what value for x equals 0. Well, I divide both sides by 12 here, and I'm left with, well, x by itself, and, well, 0 divided by 12 is 0. And so what does that tell us? That tells us here that 0 is our excluded value. We're given this problem right here, 70v squared over 100v, and we need to state the excluded value here. Well, excluded value, really with rational expressions, we're trying to find where the denominator is equal to 0, knowing we cannot divide by 0. So we take our denominator, 100v, and we're going to set it equal to 0. And now we're going to solve to find what value for v makes, well, this expression equal to 0, or the denominator. Divide by 100 to both sides, our rules still apply. Hundreds cancel, and we have v by itself. 0 divided by 100 is just 0. So the value of 0 for v, when plugged into our denominator, makes our denominator 0, meaning we cannot divide by 0, and so 0 is our excluded value. We're given this problem right here, m plus 7 over m squared plus 4m minus 21, and we need to find the excluded value here. Well, the excluded value really is when our denominator here is equal to 0. So we have to find what values, or when does that occur. So what I'm going to do is rewrite this, but in the denominator we're going to, well, factor this. We have m and m. And so what two numbers multiply to be a negative 21, but add to be a positive 4? And that's going to be a negative 3 and a positive 7. Minus 3 times 7 is a negative 21, but when we add them, we get a positive 4. So now we have this denominator that's, well, it's factored out, and we need to set it equal to 0. Now be careful here, sometimes when we simplify, we can easily cross off the m plus 7. But we have to include that to figure out what values won't work. So we take our denominator, our m minus 3 times an m plus 7, and we're going to set that equal to 0. And our rules here say we can take each parentheses individually and set them equal to 0. We add a 3 to both sides, and we have m equals a positive 3, and subtract a 7, and m equals, well, a negative 7. And so our excluded values, 3 and negative 7 here, are the two values when plugged into, well, our equation here, make it not true. Okay, it doesn't really work, you can't divide by 0. So 3 and negative 7 are our excluded values. We're given this problem right here, n squared plus 6n plus 5 over n plus 1, and we need to state the excluded values here. Well, what am I looking for? I want to take my denominator, my n plus 1, and I'm going to set it to 0, because we want to find what value makes this denominator equal to 0. Well, pretty easy to solve this. Subtract 1 to both sides, and we have n equals a negative 1. So that means when we plug negative 1 in for n, our denominator will equal 0, and that's going to cause, really, well, n equals negative 1 to be that excluded value, the value we can't plug in because we can't divide by 0. So our answer here is n equals a negative 1. We're given this problem right here, 35x minus 35 over 25x minus 40, and we need to state the excluded value. Well, first thing here is I want to take my denominator, 25x minus 40, and we're going to set it equal to 0 here. And what does that do? Well, setting it equal to 0, we're finding where in our denominator x value, when we plug it in, makes our denominator equal to 0, and that's going to tell us what our excluded value is. And remember, we can't divide by 0. So now we solve. We add a 40 to both sides, and then so we have a 25x equals a positive 40. Then from there, we divide both sides by a 25. And now x equals 40 divided by 25, which does simplify to be an 8/5. And so 8/5, when plugged in for x, makes our denominator equal to 0, which we can't divide by 0. So 8/5 is our excluded value. We're given this problem right here, negative n squared plus 16n minus 63 all over n squared minus 2n minus 35, and we need to state the excluded values here. Well, since this is a rational equation or expression, we cannot divide by 0. So we want to find when our denominator, n squared minus 2n minus 35, is equal to 0. Okay? Well, an easy way to do that is to see if we can factor this. We have an n here in the form, and we want to ask ourselves what two numbers multiply to be negative 35 but add to be a negative 2. Can you get it? That's going to be a negative 7 and a positive 5. Negative 7 times 5 is a negative 35, but when we add the two numbers, we get the negative 2. So solving this now, when it's equal to 0, we can set each parenthesis individually equal to 0. Now it's time to solve. We add a 7 to both sides, not too bad, n equals a positive 7. Subtract a 5 to both sides, and n equals a negative 5. So our two values here, negative 5 and positive 7, are the two values when plugged in cause our denominator equal to 0. And so therefore negative 5 and 7 are our excluded values. We're given this problem right here, p plus 4 over p squared plus 6p plus 8, and we need to simplify this and state the excluded values. Well, first step to simplifying is I'm going to look at my denominator and see if we can factor this. Now some form with the p's here, and we ask ourselves what two numbers multiply to be 8 but add to be a positive 6? And that's going to be a 2 and a 4. We got a plus 2 here and a plus 4 right there. So as we're simplifying, we can see the plus 4 or p plus 4 and p plus 4 here cancel out. Cancel that out, and we keep going. We're left with a 1 in the numerator, and we have a p plus 2 in the denominator. And so great, we've simplified this expression, 1 over p plus 2. But we need to state the excluded values. And normally, you just look at the denominator with a rational expression and set it equal to 0, and you see what value for p comes up. But we have to include our original problem before we simplified. So we take our denominator, the p squared, plus 6p plus 8, and we're going to set it equal to 0 from the original to find which values for p cause our denominator to be equal to 0. Well, we've already factored that. That's a p plus 2 and a p plus 4. And then from there, we can set each part individually equal to 0. P plus 2 equals 0, and a p plus 4 equals 0. When solving for p, our p, we subtract 2 to both sides, will be a negative 2, and subtract a 4, be a minus 4. And so the two excluded values here are negative 2 and negative 4, and our simplified expression is 1 over p plus 2, and that is our final answer. We're given this problem right here, 9 over 15a minus 15, and we got to simplify this and state the excluded value. Well, let's start simplifying. 9 stays in the numerator, but I see here I can pull out a 15 from both parts. So if I pull out a 15, I'm left with an a minus 1 right there. And let's keep on going. Well, 15 and 9 both share a divisor. 3 goes into both of them. 3 goes into 9 3 times, and to 15 5 times. So simplifying this, we have 3 over 5 times an a minus 1. And we're done with the simplification. There's no more, really, no way I can go anywhere else here. That's what I was looking for, I guess, to simplify this. But now we have to state the excluded value. So it's taking our denominator, which we know right here, or from the beginning, doesn't really matter. Well, it does matter, but let's just grab from the beginning, a 15a minus 15. We're going to set it equal to 0. And now we're going to, well, solve for a here. Again, we saw that simplified here. We pull out a 15. 15 times the a minus 1 equals 0. That's easier. Divide both sides by 15. And, well, a minus 1 is equal to 0 divided by 15, which is 0. We add a 1 to both sides, and a equals a positive 1. So 1 is the value that causes our denominator to equal 0, and so 1 is our excluded value. So our final answer here is simplified 3 over 5 times a minus 1, and our excluded value is 1. We're given this problem right here, 2a squared plus 10a over 3a squared plus 15a, and we get to simplify and state the excluded value. Well, I'm going to try something here. I'm going to pull a 2 out of my numerator. If a 2 comes out, I'm left with an a squared plus a 5a, right? The denominator, I'm going to pull out a 3. If I pull out a 3, I'm left with an a squared plus a 5a. Notice the repetition. Well, a squared plus 5a divided by a squared plus 5a is equal to 1. They cancel each other out. So we're really just left with a 2/3. We can't simplify that anymore. And that's our simplified expression, 2/3. But we have to state the excluded value. And to do that, we have to go back to our original expression. And we're looking at our denominator, 3a squared plus 15a. And we're going to set it equal to 0. And we're going to solve for a. What values cause our denominator to equal 0? Well, if I pull out a 3a here, I'm left with a 3a times an a plus, well, just 5, right? And that's equal to 0. Now our rules state that we can set each part here individually equal to 0 to solve. 3a equals 0, and a plus 5 equals 0. Divide both sides by 3, and a equals 0. Subtract a 5 to both sides, and a equals a negative 5. And so our two values here are 0 and negative 5, and those are our excluded values. So our final simplified answer is 2/3, and our excluded values are 0 and negative 5. We're given this problem right here, p squared minus 3p minus 10 over p squared plus p minus 2, and we need to simplify and state the excluded value. Let's go simplify this, and let's go factor the numerator. We know it's in some form of p like this, and another p. And we have to ask ourselves what two numbers multiply to be a negative 10, but add to be a negative 3. Well, that's going to be a negative 5 and a positive 2. Minus 5 and plus a 2 here. Now we're going to do the same thing with the denominator. Factor it out if we can. And what two numbers multiply to be negative 2, but add to be a positive 1? And that's going to be a minus 1 and a positive 2. Now notice here a repetition of p plus 2. P plus 2 divided by a p plus 2. They can cancel each other out. And so now we're left with a p minus 5 over a p minus 1. And that is our simplified expression. We can't simplify it anymore. But now we define the excluded values. And that derives from our original expression's denominator. We can't divide by 0, so we need to find when this denominator is equal to 0. P squared plus p minus 2, we set equal to 0. Well, luckily we already factored it. Make it easy. P minus 1 and a p plus 2 here. And now what we have to do is, well, set each part now equal to 0 and solve. P minus 1 equals 0, and p plus 2 equals 0. Add a 1 to both sides, and p equals positive 1. Subtract a 2 to both sides, and p equals a negative 2. And so our two values, 1 and negative 2, are our excluded values. And so my final simplified answer is p minus 5 over p minus 1, and the excluded values are 1 and negative 2. We're given this problem right here, x squared plus x minus 6 over x squared plus 8x plus 15, and we need to simplify this and state the excluded values. Well, the first thing I'm looking at here is I'm going to try to factor this expression. So the numerator has a form of x and x. And we have to ask ourselves what two numbers multiply to be a negative 6 but add to be a positive 1. And that's going to be a minus 2 and a positive 3. 3 times negative 2 is a negative 6, but we add the 2 and we get a positive 1. Now we're going to do the same thing with our denominator. Can we factor that? What two numbers multiply to be 15, but add to be positive 8? And that is a 3 and a 5. We have plus 5 here and plus a 3. 5 times 3 is 15, but we add the 2, we get a positive 8. Now luckily for us, we see an x plus 3 over an x plus 3. They can cancel each other out, and so we have an x minus 2 in the numerator and an x plus 5 in the denominator, and that is our expression simplified. But we also have to find our excluded values. So we look back at our original expression, x squared plus 8x plus 15, and we're going to set it equal to 0. And now we're going to solve for our x value when our denominator is equal to 0. Well, luckily we already factored this. That is an x plus 5 times an x plus 3. No need to make extra work. We now set both parts equal to 0. X plus 5 equals 0, and an x plus 3 equal to 0. Solve each one, subtract a 5. X equals a negative 5, if I can put it there. Subtract a 3 as well. And x equals a negative 3. So a negative 3 and a negative 5 are our two excluded values here. And our simplified answer, again, is x minus 2 over x plus 5, and that is our final answer. We're given this problem right here, a squared plus 5a plus 4 over a squared plus 9a plus 20, and we need to simplify this and state the excluded values. Well, first thing I want to do is, can I factor the numerator? We know it has some form of like this, a and a in the first part. We have to ask ourselves what two numbers multiply to be 4, but add to be a 5. And that's going to be a positive 4 and a positive 1. 1 times 4 is 4, but we add the 2, and we get a 5. We do the same thing in the denominator. Let's go factor this. What two numbers multiply to be a positive 20, but add to be a 9, and that is a 4 and a 5. 4 times 5 is 20, but we add the 2, and we get a 9. Well, luckily for us, we see an a plus 4 over an a plus 4. That cancels out. And so we're left with an a plus 1 over an a plus 5. And that's our simplified answer. Can't simplify anymore. Well, from here, we want to go find our excluded values. So we start with our original expression, and we take that denominator, a squared plus 9a plus 20, and we're going to set it equal to 0. We want to find when this expression is equal, well, the denominator is equal to 0, because we can't divide by 0. Well, luckily we've already factored this. That's an a plus 4 times an a plus 5, and that's equal to 0. We can set each part individually equal to 0. A plus 4 equals 0, and a plus 5 equal to 0. Subtract 4 to both sides. A equals a negative 4. Oh, 4, not a negative 5. Getting ahead of myself here. That's what I get for skipping a step. Negative 4. And we have a equals negative 5 when we subtract a 5 here. So our two excluded values are negative 4 and negative 5. And so our final simplified answer is a plus 1 over a plus 5. And the excluded values is a negative 4 and a negative 5. We're given this problem right here, x squared minus 2x minus 15 over x squared minus 6x plus 5, and we need to simplify this and state the excluded value. Well, to simplify this, let's go factor the numerator and the denominator. We know it has some form like so, and we ask ourselves what two numbers multiply to be negative 15, but add to be a negative 2. And that's going to be a negative 5 and a positive 3. Negative 5 times 3 is a negative 15, but when we add the 2, we get a negative 2. Now we do the same thing with the denominator. Let's factor this. What two numbers multiply to be a positive 5, but add to be a negative 6, and that's a minus 5 and a minus 1. Negative 5 times negative 1 is a positive 5, but we add the 2, we get a negative 6. Well, luckily for us, we see an x minus 5 over an x minus 5. They cancel, and we're left with an x plus 3 here over an x minus 1. And so this can't simplify anymore, and now it's in simplest form. But we still have to find our excluded values. So we go back to our original expression and look at the denominator. x squared minus 6x plus 5, and we set this equal to 0. Now, we already know what this is factored because we've done it. X minus 5 times an x minus 1. Our rules here state that we can set each part individually equal to 0. So x minus 5 equals 0, x minus 1 equals 0, and we're solving. Add a 5 to both sides, x equals a positive 5. Add a 1 to both sides, x equals a positive 1. So that the excluded values, 5 and 1, are the values when we plug into our original expression cause our denominator equal to 0, meaning we can't divide by 0. Therefore, 5 and 1 are the excluded values. So our final answer here is x plus 3 over x minus 1, and the excluded values are 5 and 1. We're given this problem right here, 10x minus 6 over 10x minus 6, and we need to simplify this and state the excluded values. Well, 10x minus 6 over 10x minus 6, these are the same things. They essentially can cancel each other out, and we're left with just a 1. So our simplified answer here is just 1. It's pretty easy. But we still have to find our excluded values. So we take our original expression and we look at the denominator, 10x minus 6, and we're going to see when that is equal to 0. We can't divide by 0, so we're trying to find when our denominator is equal to 0. We add a 6 to both sides. We have a 10x here equals a positive 6. Divide both sides by 10. And we have x equals, well, 6 divided by 10 is a 3/5. And so the excluded value here is 3/5. And our simplified answer, again, is 1. So be careful. This is the simplified answer, and 3/5 is our excluded value. We're given this problem right here, v minus 7 times v plus 8 over v plus 8 times v minus 10 divided by 1 over v minus 10, and we have to simplify this and state the excluded values. Well, first thing here, let's go, I don't like writing division with a fraction. Let's make this a multiplication. So we keep the v minus 7 and the v plus 8 here over, again, that v plus 8, bringing all that over from right here, and the v minus 10. But this is the same as being multiplied by, we flip the fraction here, and now we have a v minus 10 over 1. And this actually makes it a little easier to see. We can start crossing some things out that repeat. V minus 10 and v minus 10, they cancel each other out. V plus 8 and the v plus 8 cancel each other out. So what are we left with? Well, we're left with just that v minus 7 in the numerator. And so this is actually our simplified value of this expression. But we need to find the excluded values. So we actually have to look back to our original expression here, and we'll take them apart with what's going on when we flipped over the v minus 10. With rational expressions, we can't have a 0 in the denominator. Okay, so that's what we're looking at here. Be careful with this v minus 10 here, because that actually, when we're dividing it, flips up, and we can have a 0 in the numerator. That's fine. So the only thing we're really focused on is right here, the v plus 8 and v minus 10. So we set that equal to 0, v plus 8, v minus 10 here. We set it equal to 0, and then, well, we have to solve. We can set both parts now individually equal to 0, and then solve. Subtract an 8 to both sides, and we have a negative 8. Add a 10 to both sides, and v equals a positive 10. And so our two excluded values are negative 8 and a positive 10. And again, our simplified expression is just a v minus 7, and that is our final answer. We're given this problem right here, n plus 3 over n plus 2 divided by n minus 1 times n plus 3 over n minus 1 all squared. We have to simplify this and state the excluded value. Well, first thing is, when I see division with a rational expression, I'm going to flip that. So we have an n plus 3 here over an n plus 2. That stays there, but by flipping it, we're doing multiplication here. So we have an n minus 1 squared over n minus 1 times n plus 3 here. Okay, now we're going to try to see what we can eliminate. Well, I see an n plus 3 and an n plus 3 here in the numerator and the denominator. And then we have an n minus 1, and we have, well, n minus 1 squared. So we take one of these out and we get rid of the square. So what we're left with is just the 1, n minus 1 in the numerator, over this n plus 2 in the denominator. And that is actually our original expression simplified. But now we have to find the excluded values. So we look back at our original expression, but we notice there's that division again. And with our excluded values, with rational expressions, we can't have a 0 in the denominator. So that actually occurs right here. The three parts, the n plus 2, n minus 1, n plus 3. So in that whole denominator, you can probably see it like this if you want. See how I'm doing that? Make it all under one big denominator. So we're going to take that whole denominator, n plus 2, n minus 1, and an n plus 3, and we're going to set it equal to 0 to find when does this occur. But our rules state that each part individually can be set equal to 0 when solving. So n plus 2 equals 0, n minus 1 equals 0, and an n plus 3 equals 0. We subtract a 2 to both sides, and n equals a negative 2. Add a 1 to both sides, and n equals a positive 1. Subtract a 3 to both sides, and n equals negative 3. And so our three excluded values are when n equals negative 2, n is a positive 1, and a negative 3. I can put a 3 right here. Negative 3. There we go. Sorry. Not the best, but you see it now. And so our final answer here is a simplified version, or simplified expression, n minus 1 over n plus 2, and our excluded values are negative 2, positive 1, and a negative 3. We're given this problem right here, x plus 3 over 4 times 3 times x minus 6 over 3 times x plus 3, and we have to simplify this and state the excluded values. Well, first thing is we try to eliminate, cancel where we can. I see a 3 here and a 3 there. Cancel each other out. And x plus 3 in the denominator cancels out with the x plus 3 in the numerator. So what are we left with? Well, just the x minus 6 in the numerator, and the denominator is just that 4. And we can't simplify anymore, and so this is our simplified expression. But they still asked us to find the excluded values. And with rational expressions, that's when our denominator is equal to 0. Well, we can see this, if you want, as like one big expression, and multiplication here, and do another multiplication there. And we're going to set our denominator, well, equal to 0. And that's the, put it here, 4 times 3 times x plus 3 all equals 0. And we need to find what x value causes this denominator to equal 0. Well, 4 times 3 is at 12, but hopefully you can see to get rid of that, we divide both sides by 12, and it won't really matter. We have an x plus 3 on the left, that cancels, and 0 divided by 12 is 0. We subtract a 3 to both sides, and we have x equals a negative 3. And so, our final answer here is, well, our x minus 6 over 4 is our simplified expression, and negative 3 is our excluded value. We're given this problem right here, x minus 8 over x plus 6 times x minus 8, times 4x times x plus 10 over x plus 10, and we have to simplify this and state the excluded values. Well, first thing I try to do is eliminate where I can, a quick cross out. X minus 8 in the numerator, x minus 8 in the denominator, cancels. The x plus 10 here and x plus 10 also cancels. Nothing else I really see cancels, and so we're left with a 4x in the numerator and an x plus 6 in the denominator. This can't really simplify anymore, and so that is our answer that's simplified, a simplified expression, 4x over x plus 6. But we need to find the excluded values, and that is when our denominator is equal to 0. So if you think about this as one big expression, our denominator is the x plus 6 times the x minus 8 times the x plus 10. And we have to determine when the x values here cause this to equal 0. Well, we can set each part individually equal to 0. X plus 6 equals 0, x minus 8 equals 0, and x plus 10 equals 0. And we're going to solve each one. Subtract a 6 to both sides, and x equals a negative 6. Add an 8 to both sides, and x equals a positive 8. Subtract a 10 to both sides, and x equals a negative 10. And so our three excluded values are negative 6, positive 8, and negative 10. And so our final answer here is a simplified version of 4x over x plus 6, and our excluded values are negative 6, positive 8, and negative 10. We're given this problem right here, 2b squared minus 12b over b plus 5, divided by b minus 6 over b plus 5, and we need to simplify this and state the excluded values. Well, first thing is, I'm going to try to rewrite this. I'm going to flip this fraction over to be multiplication, and I'm going to factor that 2b squared minus 12b. If I take that, I pull out a 2b, I'm left with a, well, just 1b minus a 6. Denominator stays the same, b plus 5. And I'm going to multiply now, instead of divide, but we flip the fraction. We have b plus 5 here, and a b minus 6 in the denominator. Well, this is nice now, because now we can go cancel out some things. A b plus 5 in the denominator, and b plus 5 in the numerator. B minus 6 in the numerator, b minus 6 in the denominator. So what's left? Just that 2b. And the obligatory joke here, to be or not to be? That is the question. But our answer is 2b though, so that's kind of interesting. So simplified expression here is 2b. We need to find the excluded values as well. So with rational expressions, the excluded values are the ones that when the denominator is equal to 0, because we can't divide by 0. And that occurs at our b plus 5 times a b minus 6. So we set that denominator, b plus 5 times a b minus 6, because that's actually when, in the denominator here, b plus 5, when we're dividing, we're not dividing by the b plus 5. We'll be, or it's not going to be in the denominator, it flips up, so be careful with that. We set the b plus 5 times b minus 6 in the denominator, or sorry, of the denominator equal to 0, and we're solving. Set each one individually equal to 0, b plus 5 equals 0, and b minus 6 equals 0. Solve, subtract a 5 to both sides, and b equals a negative 5. Add a 6 to both sides, and b equals positive 6. And so my two excluded values are negative 5 and a positive 6. And so my final answer here is a simplified expression of 2b, pun intended, or not really intended, but there, and our excluded value of negative 5 and a positive 6. We're given this problem right here, 1 over n plus 9 divided by 6 minus n over 3n minus 18, and we need to simplify this and state the excluded values. Well, first, I don't like to have division. Let's write this as multiplication. So we have 1 over n plus 9, and with multiplication, we need to flip this fraction. And while we're doing that, let's go pull out the 3 here. So if I pull out the 3, I'm left with an n minus a 6. The denominator is a 6 minus n, but I'm going to be smart here, and I'm going to pull out a negative 1. And in doing so, this becomes, so this 6 minus n, by pulling a negative 1, is n minus a 6. Hopefully you can see that. Take your time if you need to pause and look at that for a moment. But they're the same. And now this makes it easier for me to, well, cross off some stuff. N minus 6 crosses off. And I don't really see anything else that can cross off. Well, let's bring the negative to the numerator. So we have a negative 3 here. Over what's left is just the n plus 9. And so my simplified expression is negative 3 over n plus 9. But we need to find the excluded values. So we take the denominator here, in the second part, right, what's the actual denominator, and we're going to set basically each part here equal to 0, because that's when we can't, well, basically if the denominator is equal to 0, we can't divide by 0, and that tells us the excluded value. So we're going to find the n values that cause that. So we have an n plus 9, is that equal to 0, and a negative 1 times n minus 6 equal to 0. Now we're solving. Subtract a 9 to both sides, and we have an n equals a negative 9. We won't divide both sides by a negative 1, doesn't really do anything. We have n minus 6 equals a negative 1. Or sorry, equals a 0, getting distracted here. Equals 0. 0 divided by negative 1, 0. Add a 6 to both sides, and we have n equals a positive 6. And so my two excluded values are a negative 9 and a positive 6. And so my final answer, simplified, is negative 3 over n plus 9, and the excluded values are negative 9 and a positive 6. We're given this problem right here, 28 minus 7b over b minus 4 times 1 over b plus 10, and we need to simplify this and state the excluded values. Let's go simplify first. This numerator, 28 minus 7b, I'm going to pull out a negative 7. It's making it kind of tricky. If I pull out a negative 7, I'm left with a positive b from here and a negative 4 from the 28. Put that over a b minus 4 here, and then we keep the rest. 1 over b plus 10 being multiplied. And what that did for us is I see a b minus 4 here, cross them out. They cancel each other. So we're left with a negative 7, if I can write it, in the numerator, and a b plus 10 in the denominator. And that's actually our expression simplified. But we need to find the excluded values, and that is when our denominator is equal to 0, because we can't divide by 0. So let's go set our denominators equal to 0. b minus 4 equals 0, and b plus 10 equal to 0. And let's solve. Add a 4 to both sides, and b equals a positive 4. Subtract a 10 to both sides, and b equals a negative 10. And so our excluded values are when b is equal to a positive 4 and a negative 10. And so again, our final answer, simplified, is negative 7 over b plus 10, and the excluded values are 4 and negative 10. We're given this problem right here, 2 over v squared minus 12v plus 27 times v squared minus 12v plus 27 over 3. We need to simplify this and state the excluded value. Well, don't get too caught up in just diving into this. Let's see if we can simplify this very quickly. I have a v squared minus 12v plus 27 in the denominator, and a v squared minus 12v plus 27 in the numerator. They can actually cancel each other out. And so when simplifying this, our simplified expression is just a 2 in the numerator and a 3 in the denominator. All of that very easily just becomes a 2/3. Now the hard part here is our excluded values. That's when our denominator is equal to 0, because we can't divide by 0. So in doing that here, there's no variable with that 3, so we're fine. But here we have the v squared minus 12v plus 27, and we're going to set that equal to 0 and try to find the values where this occurs. Well, let's see if we can factor this. What two numbers multiply to be a positive 27 but add to be a negative 12? That's a negative 9 and a negative 3. Negative 9 times negative 3, positive 27. Add the 2, negative 12. So now we can set each of these parts equal to 0 individually to solve. So we have v minus 9 equals 0 and v minus 3 equals 0. Add a 9 to both sides, and v equals a positive 9. Add a 3, if I can write it, to both sides, and v equals a positive 3. So our excluded values are 9 and a positive 3. And so again, our simplified final answer expression is 2/3, and our excluded values are 9 and 3. We're given this problem right here, 1 over 5p squared divided by 9p minus 36 over 5p to the third power minus 35p squared, and we need to simplify this and state the excluded values. Well, first thing is, I don't like to see a division with a rational expression, so let's make that multiplication. We have 1 over 5p squared, and we're going to multiply now, and we're going to flip this fraction. But as we do that, I'm going to pull out a 5p squared from the denominator. So let's go do that. This is going up here in the numerator. If I pull out a 5p squared, I'm left with just a 1p, okay, minus the 7. So we pull out a 5p squared from 35p squared, and we get a 7, and pull that out of a 5p to the third power, and we just have a p. But remember, we're also flipping it. Same thing here is I'm going to pull out a 9. If I pull out a 9, I'm left with a p minus a 4. Right there. Now this is a little easier to see what we can cancel out. I have a 5p squared here and a 5p squared. They cancel, and so now we're left with just that p minus 7 in the numerator. In the denominator, that 9 times p minus 4. And that is our final simplified expression. But now we have to find the excluded values. And that's when our denominator is going to be equal to 0. Okay, so that happens actually, we're going to look at this part right here. All right, being multiplied, we have our denominators. We're going to set the 5p squared equal to 0 and our 9 times p minus 4 equal to 0. And the whole point again is we cannot divide by 0, so we got to find the values, the p-values that cause that to happen. Well, here, a little easy, we divide both sides by 5, relative p squared equals, well, 0, 0 divided by 5. Square root both sides, and again, p just equals plus or minus 0, but just 0. Same thing here, we divide both sides by 9, and we have p minus 4 equals 0 divided by 9, which is 0. Add a 4 to both sides, and we have p equals 0 plus 4, which is 4. So we also have to look at, well, this part that we're dividing by. I know right now it's not in the denominator necessarily, but if we wrote it as one big fraction, it would be. So we have to find when this is also equal to 0. Our 5p to the third power minus 35p squared. We're setting that equal to 0. Well, luckily we've done the hard work right here. Remember, that's it factored out. 5p squared times a p minus 7 equals 0. Now we've already set 5p squared equal to 0. We can do that here. And we know we can set both parts equal to 0. So we set the 5p squared equal to 0, which we already got before is p equals 0. We add a 7 to both sides, and we have p equals a positive 7. So we don't need the duplicate 0, but our excluded values here are p equals 0, a positive 4, and a positive 7. And so my final answer here, simplified, is p minus 7 over 9 times p minus 4, and the excluded values are p equals 0, 4, and 7. We're given this problem right here, 8 minus 7x minus x squared over x plus 8 times x plus 5 over 9x minus 9. And we have to simplify this and state the excluded values. Well, let's go simplify this first. This numerator right here, I'm going to pull out a negative 1, and I'm going to flip things around. So if we pull out a negative 1, we have a positive x squared, a positive 7x, and a negative 8 right there. The denominator stays the same, x plus 8, and this is being multiplied by an x plus 5, and this denominator, let's go pull out the 9. So we have a 9 times an x minus 1 right there. Let's keep simplifying this. I'll do it down here. And well, I want to factor that numerator. What two numbers, remember, multiply to be a negative 8, but add to be a positive 7, and that's going to be a positive 8 and a negative 1. 8 times negative 1 is a negative 8. Add the 2, we get a positive 7. All over the x plus 8 here, and we bring down the other parts. X plus 5 over a 9x minus 1. Well, now we can cancel out where we can, right? We have an x plus 8 here and an x plus 8 there, an x minus 1 and an x minus 1. And so we're left with, just in the numerator, that negative 1, or the negative on the outside, we put it right there, times, we have the x plus 5 over just our 9. And so my simplified solution here is negative x plus 5 over 9. But we have to find our excluded values, and that's when our denominator is equal to 0. So to do that, we take our x plus 8 here, set it equal to 0, from our original expression, and 9x minus 9 equal to 0. And we solve each one individually. Subtract an 8 to both sides, and we have x equals a negative 8. We're going to, well, let's go add a 9 to both sides. So we have 9x equals a positive 9. Divide both sides by 9, and x equals a positive 1. And so my two excluded values are as x equals a negative 8 and a positive 1 here. And so again, my final answer, simplified, is a negative, then the x plus 5 over 9, and our excluded values are negative 8 and a positive 1. We're given this problem right here, x squared minus 16 over 9 minus x times x squared plus x minus 90 over x squared plus 14x plus 40. We have to simplify this and state the excluded values. Well, let's go start factoring as much as we can. X squared minus 16, that becomes an x plus 4 and and an x minus 4, right? Denominator, that 9 minus x. If I pull out a negative 1, I'm left with an x minus a 9. Multiply it out. Let's go factor this x squared plus x minus 90. What two numbers multiply to be a negative 90 but add to be a positive 1? And then it's a positive 10 and a negative 9. Same thing with our denominator. Let's go factor that out. What two numbers multiply to be 40 but add to be a 14? And then it's a 10 and a positive 4. All right, this is like my favorite part. We got a whole bunch of things here in parentheses, and let's cross off where we can. I see an x plus 10 and an x plus 10 right there. I see an x plus 4 and an x plus 4. I also see an x minus 9 and an x minus 9 here. So what is left? This is tricky. We have the x minus 4 right there, and it's being divided by a negative 1. Same as multiplied by a negative 1. So let's put that negative out front. And that's actually it. After all that, everything simplifies, or most of it does. And so our simplified answer is negative, parentheses, x minus 4. But now we define our excluded values. And that is when our denominator is equal to 0. We're going to find what x values cause that. So here we look at the beginning. We set our 9 minus x equal to 0. And our x squared plus 14x plus 40 equal to 0. And now we're going to solve for x. Okay? We'll subtract a 9 to both sides here. We have negative x equals a negative 9. Divide both sides by a negative 1, and x equals a positive 9. Not too bad. Here, well, it's easier when it's factored. We already did that work. Let's use that. X plus 10, and we have x plus 4. We now can set both of these individually equal to 0. X plus 10 equals 0, and x plus 4 equal to 0. Solving, subtract a 10 to both sides, and x equals a negative 10. Subtract a 4 to both sides, and x equals a negative 4. And so my three excluded values are a 9, a negative 10, and negative 4. And so again, our final answer here, simplified, is negative, in parentheses now, x minus 4. And the excluded values are 9, negative 10, and negative 4. We're given this problem right here, 10x squared minus 20x over 40x to the third power minus 80x squared times 16x to the third plus 80x squared over 6x plus 30. And we got to simplify and state the excluded values. So let's go simplify first. And I'm going to try to factor where I can. This first part up here, what can I pull out? Well, I can pull out a 10x. Right there. If I pull out a 10x, I'm left with an x minus 2. Denominator, again here, I can pull out a 40, lost my place there, 40x squared. If I pull out a 40x squared here, I'm left with an x minus 2 again. Not too bad, not too bad. Now we're being multiplied, or going to multiply, okay? Again, we want to factor out that numerator, and we can pull out here a 16x squared. It goes into both parts. Pull out a 16x squared. We're left with an x plus a 5. Okay? Denominator, same thing. We're just going to pull out a 6 here, and we have an x plus a 5. So I'm just double checking, making sure I got them all. I did. So now we're going to cross off where we can. X minus 2 can be crossed off here. X plus 5 gets crossed off. This x plus 5 gets crossed off as well. Okay. Anything else? Well, I see an x squared, and an x squared can cross off right there. The 10 and the 4, I can cross off the 10, and this becomes just a 4 there. A 4 goes into the 16 4 times, so I'm going to do that there. And now we have 4 over 6. Well, 2 goes into both of them. So this is a 2, and this is a 3. So after all of that, can't forget it, we have this one little x here in the numerator, and that 2, so don't forget that x. So we have 2x here. Over denominator, the only thing left was that 3. And so our simplified expression, after all that, is just 2x over 3. But now we define our excluded values, and that is when our denominator is equal to 0. So we want to find where we're dividing by 0 and we have to exclude those values. So we're going to take our two denominators right here from the beginning, 40x to the third minus 80x squared. I'm going to set that equal to 0, and 6x plus 30 equal to 0. Well, luckily we already did some factoring here. Pull out a 40x squared, and that's going to be an x minus 2 equal to 0. Well, with that, we're going to set now both of these now equal to 0 to solve. So we have 40x squared equals 0, and x minus 2 equals 0. Divide both sides by 40 here, and we have x squared equals 0 over 40, which is 0. And we square root both sides. Plus or minus 0 is the same, and so x equals 0. Here I added 2 to both sides, and we have x equals a positive 2. This one now I also have to solve. So I'm going to subtract a 30 to both sides. We have 6x equals a negative 30. I now divide both sides by 6, and x equals a negative 5. So we have negative 5, positive 2, if I can circle that right, and a 0. And so our excluded values, we're dividing, if we put this into our expression, we're dividing by 0, so we have to exclude that, is when x is 0, a positive 2, and a negative 5. And so my final answer, simplified, is 2x over 3, and the excluded values are 0, 2, and negative 5. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math, when you need help you use Minute Math.